So this is the second example that we did in class this week, but I just want to go back through it. We're going to start here. We're pulling this cable up at, we'll say, a constant velocity, so it's in equilibrium. We're pulling the car up using this cable. Cable's at a 31-degree angle with the incline, and the incline is at a 25-degree angle. We know the mass of the car, and we want to determine the tension in the cable and the normal force that's on the car. So to do this, we've got to write two equations for the x and y dimensions of this situation. Aside from the normal force and the tension on the cable, assuming no friction, the only other force that's acting on the car is the force due to gravity. If we set our coordinate system to align with the incline itself so that the positive x direction runs up the incline and the positive y direction would then be perpendicular to the incline. If we do that, then the normal force is in the y direction, and we have a component of t in the y direction. There are components of gravity in the y and the x direction, and there's a component of tension in the x direction. So by doing that, we can simplify the way we write these problems and the way we write our two equations. So you can see how you can break up the tension into two components, assuming that the positive x direction is up the incline and positive y is perpendicular to the incline. We can break the gravitational force into components, one that points directly into the incline and one that points down the incline. And remember that the angle is still 25 degrees. And so if we start with the x direction, the sum of the forces in the x direction, positive tension force up the incline minus the negative gravitational force down the incline, and that's going to be equal to 0. And we know that the tension T times the cosine of 31 degrees should give us the component Tx. The magnitude of the gravitational force is m times g, which is the weight. When we take into account that this force is pointing down the incline opposite this angle, then the component of gravity that points down the incline is going to be m times g times the sine of theta, or the sine of 25 degrees. And now, unlike in the previous example, in this equation, we know everything except for t, and so we can solve for t by just plugging in everything that we already know. Then dividing both sides by 0.857, we find that the tension in the cable is 5,460.99 newtons. Because we know T, we can now find the y component of the tension by just using that value times the sine of 31 degrees. And you find that the y component is 2,812.62 newtons. So now we need to use the y dimension to find the normal force. In the y dimension, the tension in the cable and the normal force work to essentially counteract the force due to gravity. So we can plug in the tension force that we know. The normal force is what we're looking for. We can determine the gravitational component that's perpendicular to the incline using the cosine of the angle. And in doing all of this, solve for the normal force. And you find that the normal force is equal to 7,223.83 newtons.